Now we're going to learn how to set up and solve proportions from a word problem, which is our essential question. So what we need to do is draw a picture of the similar figures that the word problem is telling us about so that we can set up our proportion from there. Our first question is about figuring out how tall a flagpole is. So Jane knows how tall she is, and she can measure her shadow. So we think about if the sun is over here, Jane is casting a shadow, and then there's a flagpole also casting a shadow at the same time. The rays from the sun create the same angle for Jane and the flagpole. So we have similar right triangles, so we can label the information we know and solve for what we don't. We know Jane is 5.5 feet tall. She measured her shadow to be 3 feet. She measured the shadow of the flagpole to be 12 feet, and our question is, how tall is the flagpole? Once we have our picture, we can set up our proportions from there. So x over 5.5 is the same as 12 over 3. Solving for x, we're going to multiply both sides by 5.5 to cancel our division. So the flagpole is 22 feet tall. Next, we're trying to find the distance across a lake. Again, not something that's real easy to measure, so we can set up similar triangles. So we can see we have two similar right triangles. Make sure you are looking at the large triangle and not the trapezoid that is created here. A trapezoid is not similar to a triangle, so we've got to use the right piece of information. Setting up our proportion, we can start with the distance across the lake corresponds to the side of 40 meters in the little triangle. Now we have to look at the whole big side because we have to look at the big triangle. So we're going to add 320 and 162 to get the long side in the big triangle, which is a total of 482, over the long side in the small triangle, 320. Solving, we're going to multiply both sides by 40 to cancel our division. So the distance across the lake is about 60.25 feet. Finally, we can look at the scale on a map. Every map has a scale that tells you how far apart cities actually are based on how far apart they are on the map. So the map is drawn what's called to scale, meaning the ratio of the distance between cities is the same on the map as it is in real life. So it's proportional. We're looking for how far apart the cities are in real life, and we were told that in real life they would be 50 miles apart if they are 1 centimeter apart on the map. So notice the 1 and the 50 correspond because they're both on the map, and the 3.75 correspond because on the map they are 3.75 centimeters apart, and in real life they would be X number of miles apart. We do not have to convert because of the way that we set up our proportion. We have the centimeters go together and the miles go together. Our answer will be in miles. So we multiply both sides by 50 to cancel our denominator, and 3.75 times 50 gives us a distance of 187.5 miles. And your you try question. Remember to set up a picture if it's helpful.